Hello and welcome to Innovation. In today's program, we're going to be two young gentlemen who are working hard to inspire young Tanzanians to enjoy, to love, and to work doing science and technology. I have none other than Boniphace Elfas Kanyathare, and they have an organization called ASAP Education. Tell us a little bit, what is ASAP?
ASAP is the short form for After School Academy Program for Education. Actually, we came up with that name because we are trying to inspire the youth not only to think about science in terms of only day-to-day studies that they have in class, but to think of it as something that they can do within the studies period, is something that they can do after their studies, and is something that they can do in life. Something that can change their lives and the lives of the community around them.
Just let's have a look at the situation currently overall. We're looking at innovation. We're seeing a lot of Tanzanians, young Tanzanians, really coming up with some great stuff out there. But it all ends, we don't really get to see it, actually taking place in terms of, let's say, it comes into reality. I'm talking about young people that come up with these innovations, but they just end up being ideas, Why is that taking place, do you think?
One of the reasons why I think this is happening is there is kind of mismatch or misconnection between our older generation and the younger generation. Because for these things to work, for example, people who are making policies, people who are in positions are the older generation. And mostly people who are coming with these innovations are younger generations. And maybe this is one thing I'll say also about our system of education, because in our country, for example, we are talking about Tanzania and mostly Africa in general. Our people who are educated, let's say having PhDs or professors, is like they are kind of a different breed compared to the masses. So this creates some kind of isolation. Rather than education becoming a bridge to bridge us together, it is creating walls. So in that way, we, the so-called the educated, for example, should go down to earth and be able to discuss things with those people, and then through collaboration together, I think our country can get somewhere. Because for sure, we have a lot of people who are inventing these things, but majority of those people does not have higher levels of education.
What can you say about the kind of innovations the young Tanzanians are doing right now?
We have potential. The youth of our country have potential. We have potential. Normally I say it, we have potential to do anything we want to do. And the innovations that are going on around are nice innovations. For example, I'll give an example. I'm a lecturer at DIT. Here at DIT, we have students who are doing final year projects. There are nice projects that are coming up, year in, year out. But the problem is taking these projects further.
Okay, so let's talk about what you guys are doing to make sure that the young people there get to enjoy, get to like doing things like, science and technology, for their future. It's not something that most of us think that once you've graduated, you're going to be employed somewhere. But things are not that way right now. We must think that once I've graduated, I'm going to be self-employed.
I can say that the mentality we've talked about of just thinking of employment, it is something that is ingrained in us from the very beginning, from our lower levels of education. As a child comes up, for example, you will be taught in class about physics, chemistry, or mathematics, but no one tells you why this is important. Why should I care about it? Because of course there are a lot of subjects, and we know in order to have people who are competent, these people should be focused and dedicated. So we can study a lot of things to have a general understanding, but then we have to narrow down and focus in a certain area. For that to happen, we have to explain to our youngsters to make them know. If, for example, let's say I'm teaching mathematics, I'm teaching physics, I should make them know why is physics important? What can physics do? So, for example, one of the things we do in our group in ASAP Education when we go around schools, we try to explain to our students three most important things. The first thing is showing them the importance of science and technology in the development and growth of our nation. So we take an example, for example, of the ongoing massive development projects that the government has embarked on. And so we tell them that you see what is happening. Everything that is done there, 80% is science and technology. So we ask them questions. this is something that is happening. This is science and technology. You see a lot of people who are dealing with these projects are foreigners. So we ask them, are you ready to live in a country where forever, perpetually, the people who will be, dealing with these projects for you are foreigners? They say no. So you see, science is important. So we managed to convince them with that. The second thing is trying to show them the relevance of what they are studying in class in terms of solving real-world problems. Because sometimes a person says, this is science, but this science, what I see, the application of this in maybe in advanced countries. But we tell them, for example, they study physics, things like resistors, things like capacitors and diodes. We show them, you see, from capacitor, resistors, and diodes, you can create this circuit, which is a power supply, and you can use this power supply to power another circuit like this one. This is a display, which you can use for displaying things. But as we'll go along, we'll see some other circuits where you can apply this and make a product which, for example, can detect thieves, can detect robbers. So we show them that through these simple concepts you are studying, you can develop this. So that shows the relevance of what they are studying, and it helps them to really want to do science.
Show us the kind of innovations that you use to teach the young about innovation and technology.
Yes.
Yeah.
Here we have a couple of several circuits.
And these are your own inventions?
Yes, these are things that we have designed and made on our own. These are not ordered from China. Of course, we order from China individual parts and components because in our country we don't have factories that manufacture these individual small pieces of components. But you have to think of how to assemble these together and really make a product. That takes kind of education.
But otherwise, most of the stuff is available in the country.
Yes, these things we import them from outside.
Okay.
Yes, we import them, so some from China, some from the West, and then here they come, as I've said, as parts. But now we design on our own. We design and fabricate and make everything. As you can see, for example, these circuits.
What is okay?
Here you see, these have been fabricated. We have fabricated it here locally.
And what do you use this to teach for?
Okay. When we talk about, let's say, secondary students, for secondary students, there are several things that they study. One of the things they study that is very important is power supply. Power supply. And when we talk about power supply, if you talk about any electronic device, it needs power. So power supply is something that is very important for someone to be able to go further in electronics. Power supply is like the cornerstone. So this circuit here that I'm going to show, this is a power supply. This is a power supply as it is. So it has a transformer, basically taking the AC signal from Tanesco, taking it down to an acceptable level. And then from this transformer, we have something called rectifier. We have 4 diodes here connected back to back, connected together. This is a bridge circuit. So what this bridge circuit does is it is called rectification. It converts a C signal, alternating current signal, to direct current signal. And the students study all these in their Form 4 when they study electronics in Form 4. So from here, we have something called the capacitor. Capacitor is used like a filter. It filters the signal to make sure that DC. Electronics things require signal that is constant, that is not fluctuating. So this makes sure that it makes sure that it eliminates the AC components and makes sure that the DC that we are getting is stable. And then we have something called a voltage regulator, which makes sure that the voltage coming outside is the required voltage, so it doesn't go up and doesn't go down. And so from here, this power supply can be utilized or used for powering other circuits. This is another circuit here. Basically, it's a display. I think you've seen a lot of displays around which of this nature. So for example, here we have written a letter TZ, Tanzania. So we can make this very big and very huge, and then you can write whatever letters you want, you can write whatever words you want. So these are simple things, but these are very appealing to the youth.
How is it that you do to make sure that, because you can get some people who are interested, but when you teach, it's the way that you teach them that, sometimes I find, okay, he makes it difficult. It makes it difficult to understand. How do you do it to make sure that, you see there's a young person there who has the potential to learn, and to draw them to make sure that they use the potential, they use the talent, they grow the talent?
Yes. The first thing is always mentality. And a lot of the concepts that people have, the negative notions about science that people have, normally comes from the mentality. So the first thing that we do is, first of all, telling them that this is possible. Don't worry. you can do it. You see all these things around here? You see, it's us who have made this. So if we have made this, we can teach you, you can do it. So that is the first thing. But as I told you, we try and tap from the curiosity. So we don't start away by explaining them about different tough concepts of you know, circuits and theory, circuit theory.
Put them off.
No, that will put them off. So we show them the interesting part first. And once they grasp this, and it's interesting to them, it kind of sparks that curiosity more and more, and then they become even more curious and start becoming, now he starts, okay, so this is doing this, so what is this doing? So you start explaining now about the principles a bit, and you just do it one step after the other. You don't
cram everything in one go.
Everything together in one day. No, you explain this slowly by slowly. But actually, the explanation that we do is more through doing and measuring than just equations on the board, because most of the teaching methodologies that are available is just on the board. We are solving equations, we are deriving circuits, and so on and so forth. But it doesn't show these kind of interesting things. So we make sure we do that.
All right. Okay, so what else have you got to show us that maybe you teach in your classrooms?
We have another very interesting circuit here. The circuit, what it does, it detects, it's called an intruder alarm. So it can detect, yes,
young people like that, huh?
It can detect the presence of a person if in an area that is restricted, let's say, or at night if people are sleeping, it can detect if a person is present. If it detects that, then we have a sensor here. This sensor is the one that really detects the presence of a person, and then it sends signal to the brain here. I call this a brain, we call this the processing part. It processes the signal. So it takes the signal to this part, and here is where the decision is made. This is like, we have something here called microcontroller. Microcontroller is like a small computer. So it takes inputs, it calculates, and then it gives an output. So the output is the one that can produce sound through this sounder, or it can give out lights, as we'll see here, or at the same time, of course, the other thing that we have here is status indicator. So this is a display that can show on the screen what is happening, that maybe someone is detected. Okay, the lights are going on now, and so on and so forth.
You know, when you start putting something together like this,
Yes.
yeah, what is the first step that you do?
Okay, the first step that you have to do is just idea. You have to think of what you want to achieve.
So with this, what did you want to achieve?
What we wanted to achieve here is to create or design a circuit which can scare thieves away by giving sound and also giving an indication of light, because that becomes more serious. You see, he hears sound and he sees things doing like this, so he'll be confused. He can even run away. So that is what we wanted to achieve. So to get that, or to have that, now we go through the simple concepts of designing. Okay, I know if I want to have such kind of a circuit, I must have something that can detect the presence of a person. Okay, I need something to detect. After that, I need something that will know that somebody has been detected. Okay, after that, I need something that after the detection, if I know someone is detected, I must warn that person or give an alarm. So I need something that will give an output which will give sound. Okay, so I need a speaker or a buzzer. Oh, I need a sensor at the input. Okay, now which part will really make these decisions? Oh, I need something like a computer which actually receives inputs and gives a certain output. So I need something like a controller, a circuit. So we can have this sophisticated circuit, and we can have also other simple circuits. But this is better because this can perform a lot of multiple actions. That's why you see, as I'll indicate here, we have an output of light. At the same time, we have an output of sound. So it receives multiple inputs and it can give multiple outputs.
So what was the first thing that you started with when putting this together?
The main important thing, we have to know which signal is coming from the sensor. So this sensor, for example, it gives a certain voltage. Okay, so we have to understand that. So I know, let's say I'm talking about a voltage, whether it is, and mainly here it gives a DC voltage. So how much, what is the amount of that voltage? After I know that, now I know, okay, I have 5 volts, for example, that will be coming in the output, in input, or maybe 3 volts that is coming in the input. Then from there, how can I tap this incoming signal and connect it into the decision-making process. So the central part is actually this controller, microcontroller. Yes. So it has inputs, it has outputs. Yes. This microcontroller here. This is a microcontroller. Okay. Yes. So this receives the signal. So it means all that I'm explaining is like in form of a concept. So we conceptualize. After making that and doing some simple calculations, recognizing the input, knowing that this can respond to the output, we do something called simulation. Before you actually build something like this, you simulate first to see that the concept that you have in your mind, is it really actual? Can it really give the output you want? So we do that through the computer. There's electronic softwares where I put this in the circuit, I create this circuit in the computer, and it gives response. And then after that step, I can use this. This is called a Voirobot. What does it do? Here, I can create kind of a similar circuit. I can create a similar circuit. This is not meant for the industry. This is meant for prototyping before actually creating a real product. Because you see what we have here. Let me turn this around. You see this one? Yes, it has been fabricated already. But because if you do this and it doesn't respond as you want, it means you have done a lot of work and then you have to start all over. But if I use this without connecting everything at the end, because here I can put components and take them away straight away. So if I assemble it here, and it works perfectly, then I can create this we call PCB, printed circuit board. And then I can transfer all those to that printed circuit board and connect it. Because now I'm sure that if I connect it here, as long as it was working here, even if there are some challenges, very minor challenges.
So I'm with Elekia right now, and he's going to give us a demonstration of how this actually works.
Firstly, he will detect the presence of person through this sensor. We call it PIR sensor. Yeah. So it detected the movement there. So when it detects it,
My cameraman.
yeah, your cameraman. So person detected, yes.
Now it's going crazy because of my camera person. Nelson, move out of the way. Oh my goodness.
So as you see there, after time it will turn off.
Okay, because it's moved out of the
Yeah.
way. This kind of innovation that you take with you to the schools, what has the response been so far from the pupils? Are they enjoying themselves? Do they find the lessons interesting? Have you noticed there's a lot of talents there?
We heard some comments from some of the teachers. They are actually the ones who are insisting, you have to make sure this goes countrywide. The response was very positive. The students were very enthusiastic. There are students, especially some of young girls, who declared right away, I'm going to study science. And actually, you know the importance of this. Let's say at secondary schools, when a student starts Form 1 and already is interacting with this, when it comes at the end of Form 2, when they are trying to choose the combination, it will be an easy job because their curiosity and actually the beauty of science will be already ingrained in them. So they won't think of science as something hard and difficult. They'll see science as something that is very relevant to their day-to-day lives. So even because we have a cry in our country now, very few students, for example, as ASAP Education, we visited one school. Out of 246 students who have registered for Form 4 final exams, only 18 are doing science.
What else do you also teach these young people?
Okay, we have a system like this. This is a system of security cameras, CCTV cameras. Why do we go with this one? Of course, there are some of technologies that are already in the market that can be imported from abroad. But even with these technologies, we want people who can maintain these technologies. We want people who can install these systems. We want people who can actually rectify in case there is any kind of a problem with the system. Otherwise, we'll be just finding people from outside to come and do everything that we have, something that is not good. So one thing with this is we show them the potential opportunities. And actually, we use this to convince even guys studying art that you can do science. Even if you have not taken science here, still you can go to several colleges, you see, in VETA, and you can study things like this because this thing is something you can study. Because if a standard 3 can study this thing and do it marvelously, what about a Form 4 leaver who has not taken science, you see? So we use this to show them potential opportunities that are available for people who venture into science, people who like science, people who want to play with science. Because of course, to do this, at least even if you have not studied science, you should be a little bit curious and you should have kind of a love for science.
Okay, so how do you go about showing them, to enjoy doing
For example, to enjoy this, for example, there are several cameras here, but mainly the one we have here is called PTZ camera. This is a very powerful camera. It's a camera that can capture the scene from a very far distant angle or view. And at the same time, it's a camera that has multiple functionalities. For example, I'll show you here one functionality. This is a camera that can rotate. It can rotate up and down. It can rotate horizontally as well as vertically. So with this camera, for example, I think if you go around close to International Labour Office, close to Holiday Inn there's one camera of this sort. So we try to show them, because this can be used by watch guards to monitor what is going on around, and they can use it even to track the target. Okay, for example, this camera now, as you can see, it has three functionalities actually. It's called pan, tilt, and zoom. Pan is movement in a horizontal direction. Tilt is movement vertically, upwards or downwards. And then zoom is actually pulling something and bring it more closer. Of course, the challenge here is with us, we are very close, so the zooming won't be that good, but let me show. We start with, let's say, pan, rotating horizontally. So you can set this so that it goes automatically, but also you can do it manually. So you see now, for example, what is happening. Yes, it is panning.
Yes.
It is going,
Yeah.
you see. So it means you can use it to track the target. If a person is going there, is shifting to this place, as long as it is within the view of the camera, it can capture. So these are one of the things, and because this is like a software, the brain of this system is like a computer. It shows the students the beauty, and so they actually see the beauty of science from this, what is happening here, because I'm commanding something here, and it is happening here where we have
the brain?
The brain is here. This is called the digital video recorder. This is the brain. And so that is pan. Tilt, I can do it this way. Okay, maybe it is gone up. You see?
I can see it
You see?
tilting.
Yes, it is tilting. It is tilting. Yes. So these are different functionalities that the camera has. And also we can do, for example, let's say a bit about maybe zooming. So zoom, let's say, I think you can see the scene that it's coming closer and closer and closer and closer. So this is very powerful. It can capture something from something that is maybe even 100 meters away. It can bring it clear, and you can see a person and really recognize this is someone. So we use this to actually show them. These are some of the potential opportunities. There are a lot of others. We have another system that we will not show today here. We have another system that controls, let's say, we call it access control system, the electronic system that you can use for closing and opening the doors automatically by swapping the card, by using fingerprint. All those are potential opportunities that are available. And a lot of those jobs inside our country are done by foreigners. So we try and show them that, no, this is something we can teach you. And if we teach you, you understand, you can master it. Even for ourselves, we didn't master within one day.
When we look at innovation in Tanzania,
Yes.
we're looking at young Tanzanians.
Yes.
Where do you find Tanzania on the world map?
In the next 5 years, as I said about the potential, we have the potential. Now it's up to us as a country, because our current government has embarked on a journey that wants to ensure that we are self-sufficient. Okay? In that way, even if we are thinking of other developmental areas, we cannot forget to think about our innovators. We cannot forget to think about our youngsters. And if we can look at several innovations that we have, young people that we have, if we can bring them together, if we can find mechanisms to support them, because what is lacking is just support, nothing else. The brain is there, the exposure is there, the want to do it is there. For example, for us as ASAP Education, this is something that we have embarked on. It is something that for us we call it a do or die. It's something that we want to do for our lifetime. It's something that we love to do. It's something that no one has compelled us to do. We have decided on our own that we want to do this thing because this is something that is going to change our country, and we want to have a legacy. We want to change our country. So, of course, we cannot achieve this on our own. This is a massive endeavor because we want to make sure that these components get to schools, secondary schools, possibly to primary schools. We want to make sure that we have several centers, even if not to each individual school, because also we still don't have the capacity of teachers in each and every school to be able to deal with things like this. But we are thinking of creating centers all across the country in different areas, to have different centers equipped with these things, equipped with the right mentality, trained, facilitated to make sure that we achieve this. As I've said, we cannot achieve this alone. We are going to do it, but we need the collaboration and the cooperation from different stakeholders. For example, I'll give an example of one organization called MITZ Innovations. This is a group of youngsters also who actually graduated from UDOM. They are based in Mwanza. They are also doing kind of a little bit similar initiative, but they are dealing with individual components. You see, our initiative is combining those individual components and showing the relevance in terms of solving the challenge. So if you combine the things that we have and the things that MITZ are doing, if these things get to schools and we find modality of training some of our teachers, training our youngsters, and this is something, as I've said, we need our government to get involved in this. We cannot achieve this alone. We want people like COSTECH, ERB, Tanzania Academy of Sciences, organizations like NIMRI, our institutions to get involved in this. Because if we manage to implement this in our country, this is going to be a game changer. And I think if we are really looking towards an independent Tanzania, Tanzania which is industrialized and self-sufficient,
This is the way to go.
we cannot forget this. This is something that we have to pay the price. We have to invest in this. So we are talking about academies of, let's say, football and so on and so on. For us, our initiative is, this is an academy for science, innovation, and technology.
That's it from Innovation Today. Join us for another edition next week, same time, for more innovative solutions.